Picture this: an ambulance is blaring its sirens, racing toward a hospital with a critical patient inside. But a self-driving car ahead doesn't realize it should pull over. It just keeps going, blocking the emergency vehicle completely. Sounds like a nightmare? Well, it's happening right now on real streets in real cities, and the federal government has just caught autonomous vehicles red-handed doing it systematically. The National Highway Traffic Safety Administration, the NHTSA, just released a stunning report calling out self-driving cars for failing to respond to emergency vehicles. This isn't some edge case or rare glitch you might read about once a year. It's widespread. Autonomous vehicles across multiple manufacturers aren't pulling over for ambulances, fire trucks, or police cars. They're not slowing down properly. They're creating dangerous delays when every single second can mean the difference between life and death. Here's what makes this absolutely wild. These cars are supposed to be smarter than human drivers. They have 360-degree sensor awareness. They are constantly connected to mapping data and real-time traffic information. Theoretically, they should be the absolute best at detecting sirens and moving out of the way. But instead, they are failing at something a teenager with a learner's permit learns by pure instinct: get out of the way when you hear an ambulance. Think of it like having a traffic officer who sees an ambulance coming but just stands there frozen, completely confused about what to do. To understand why this is such a massive deal, you need to know where autonomous vehicles actually are right now. We're not talking about some distant future fantasy. Tesla's full self-driving is on public roads with hundreds of thousands of vehicles. Waymo's robotaxis operate in multiple cities. Uber's cruise robotaxis are testing in San Francisco. These aren't lab experiments or pilots. They're actively sharing roads with emergency services right now, handling real traffic. The problem is straightforward. Developers built these systems to handle normal driving. They train their AI algorithms on millions of hours of routine traffic, lane changes, speed limits, parking, emergency response scenarios. That wasn't the primary focus. It's like building an aircraft autopilot and forgetting to program how it responds when air traffic control radios an urgent redirect. Regulations have badly lagged behind actual deployment. The NHTSA didn't have detailed requirements about how autonomous vehicles should handle emergency sirens until very recently. Companies pushed their technology into San Francisco, Phoenix, Las Vegas, and beyond. It was like letting cars drive themselves without finishing the safety rulebook. Meanwhile, emergency responders were dealing with the consequences. The regulatory awakening is recent. As autonomous vehicles became common, emergency responders started complaining. Ambulance crews noticed self-driving cars not moving aside. Police departments reported problems during actual emergency calls. That's when the NHTSA paid close attention and demanded answers from manufacturers about what their systems actually do when sirens are blaring. And what they discovered was shocking. So what's actually going wrong under the hood? The core issue comes down to object detection and priority algorithms. Autonomous vehicles constantly process their environment: other cars, pedestrians, lane markings, traffic lights. These systems have a decision hierarchy, a priority list of what matters. But here's the fatal flaw: emergency vehicles often aren't properly coded into that hierarchy. When an ambulance sounds its siren approaching from behind, a human driver hears it and responds instantly. But an autonomous vehicle's audio processing might not even register the siren as a safety-critical event. The algorithm might detect the ambulance as just another vehicle and continue its planned route. Even if the siren registers, the system might not know how to respond. Should it brake hard, slow gradually, switch lanes? Different manufacturers program different responses, creating inconsistent chaos. Here's the problem made concrete: emergency vehicles drive unpredictably. They weave between lanes, make sudden turns, drive against traffic. Autonomous systems trained primarily on routine highway behavior get completely confused by these exceptions. They lack the contextual reasoning a human driver uses instantly, that immediate gut understanding that emergency vehicle means move aside now. Additionally, some autonomous vehicles were tested in controlled environments with ideal weather. Real emergency response happens in messy, complex scenarios: rain, darkness, traffic congestion. These variables weren't always part of the training data. The NHTSA discovered that some vehicles literally have no siren detection capability built in. They never received that programming. It's like discovering a car's emergency brake was never installed because nobody explicitly programmed it during development. Let's make this concrete with real examples of what's actually happening in cities right now. In Phoenix, Waymo robotaxis have been caught blocking ambulances during live emergency response. The self-driving vehicle didn't recognize the ambulance as requiring special priority and just continued its route. Emergency responders had to wait for the robot to move, costing precious minutes during a medical emergency where timing is everything. In San Francisco, Tesla vehicles with full self-driving encountered similar failures. Ambulances approached with sirens blaring and encountered autonomous vehicles that didn't yield or slow down properly. In one documented case, an emergency responder described following an autonomous vehicle that seemed completely oblivious to the ambulance right behind it with all lights flashing. Tesla's specific challenge is architectural. Full self-driving relies primarily on cameras and radar for navigation. It processes lane markings and traffic patterns visually. When an ambulance approaches from behind, the system sees flashing lights, but the priority logic doesn't flag this as emergency status. The car cruises onward. Some autonomous vehicles aren't even listening for sirens. Their architecture never included sound detection at that level. If an ambulance approaches around a corner or blocked by other traffic, the autonomous vehicle receives zero warning. It's driving blind to acoustic emergency signals. The NHTSA found this happening not as isolated incidents, but as patterns across multiple manufacturers and multiple incidents. This isn't one bad software update. It's a fundamental design oversight replicated across the entire industry. One manufacturer might detect sirens correctly. Another might ignore them entirely. Now here's what makes this comparison shocking. Human drivers have roughly 1.5 seconds of reaction time after hearing a siren. A human immediately understands the priority, get out of the way. We are wired for this response across almost all drivers and situations, regardless of age or experience. Autonomous vehicles could theoretically respond faster. Algorithms can process in milliseconds, but they are failing at the first step. They don't even recognize that something critical just happened. Here's the fundamental difference in decision-making. A human driver makes contextual choices. If an ambulance is behind me and there's no safe gap to the left, I brake to create space. I understand the emergency and cooperate. An autonomous vehicle just follows its programmed lane rules, treating an ambulance like any other vehicle. The numbers are absolutely damning. In 2024, human drivers yielded to emergency vehicles correctly roughly 85% of the time. Self-driving vehicles in the NHTSA study, some manufacturers' systems yielded correctly less than 40% of the time. One manufacturer's system yielded correctly only 12% of the time. That's not a technological advantage, that's catastrophic failure. The real problem is that teaching an AI system to understand context and make safety-first decisions turns out to be harder than most engineers originally realized. You can train a neural network to recognize objects and follow road rules. But teaching it to say this situation requires me to break my normal programming and prioritize differently. That's a completely different challenge. This discovery raises urgent questions about the entire autonomous vehicle rollout timeline and readiness. If self-driving cars can't reliably handle emergency vehicles, they're not ready for public roads. This is a safety baseline, not a luxury feature. Imagine a city with thousands of autonomous robotaxis, and emergency response times increase dramatically because those robots don't know to get out of the way. You're not just inconveniencing one ambulance. You're potentially cascading delays across the entire emergency system. You're affecting outcomes for patients, for fire response, for police operations. Here's what's alarming. We're already deploying these systems at massive scale. Waymo operates hundreds of robotaxis across multiple cities. Tesla's full self-driving has nearly 1 million users. Cruise operates in San Francisco. These aren't pilots. They're active, expanding operations with real consequences when they fail. And these systems have been operating without validating this basic safety feature properly. The broader implication is that manufacturers rush deployment without thinking through edge cases, scenarios that don't fit normal driving patterns. Emergency response is one. What about construction zones, school buses, funeral processions? Every scenario requiring special behavior reveals potential gaps. We're discovering right now that training was incomplete. This also damages the credibility of autonomous vehicles themselves. The original promise was that robots would be safer and smarter than humans, but being demonstrably worse at basic emergency response shatters that claim. It tanks public confidence. So what's the NHTSA actually demanding from manufacturers? And more importantly, how do companies actually fix this problem? First, transparency. The regulatory agency is requiring manufacturers to detail exactly how their autonomous vehicles respond to emergency vehicles. That means open documentation, siren detection protocols, decision logic, response behaviors. Companies can't just say our system works great. They have to prove it with data. Second, manufacturers need to implement and test specific emergency response protocols. This means programming the vehicle to recognize sirens at certain decibel levels, detect emergency vehicle light patterns, and respond with appropriate actions, yielding, pulling aside, slowing down. It sounds basic because it is basic, but it was completely missing in current systems. Third, testing needs to be comprehensive and real-world, not just highway simulations. Testing in rain, at night, in heavy traffic where sirens might be partially masked. The NHTSA wants validation data that shows these vehicles can reliably, consistently, repeatedly handle emergency response scenarios in messy real conditions. Fourth, there's an enforcement component. If a manufacturer's autonomous vehicle fails these tests, deployment gets restricted or scaled back. That's the regulatory stick. The carrot is that companies nailing this become the trusted players in the market. There's also discussion about universal standards. Right now, every manufacturer can build their emergency response system differently. The NHTSA is considering mandating industry-wide standards so that an ambulance driver can predict how any autonomous vehicle on the road will behave. Consistency equals safety. For some manufacturers, this isn't just a software patch. It's a fundamental redesign, adding microphones, upgrading processing power, reworking the entire decision hierarchy. Here's what this means for you and the future of autonomous vehicles on our roads. In the short term, expect deployment to slow down. Companies will spend months validating these emergency response systems. Cities might impose restrictions on autonomous vehicle operations in certain areas until safety concerns are properly addressed. That robotaxi service you are planning to use might face temporary limitations or expanded testing requirements. But here's the silver lining. This is exactly how safety regulation should actually work. We're catching problems before they cascade into disasters. Yes, autonomous vehicles have major flaws, but those flaws are being identified and regulated in real time. That's regulation working correctly, not blocking progress, but ensuring progress is actually safe. The bigger picture is this: autonomous vehicles aren't disappearing. They're going to be on roads for decades. But this NHTSA intervention proves they need oversight, rigorous testing, and accountability. The technology is powerful and potentially valuable, but power without responsibility is dangerous. What to watch for next? Announcements from major manufacturers about how they are addressing emergency response. Watch for third-party safety testing and certifications. Watch whether the NHTSA follows through with enforcement when companies fall short. Watch whether this becomes a competitive advantage, some manufacturers genuinely solving this versus others cutting corners. The takeaway here is that autonomous vehicles are tools humans created, and like all powerful tools, they need rules, rigorous testing, and oversight. We can't deploy advanced AI at scale and hope it works out.